Hi, this is Maggie. In this video, we're going to look at how to desk check and debug a program with lists. This video assumes that you already know how to desk check and how to use the idle debugger. So if those tools are unfamiliar to you, you should review the sections of the textbook that go through them, or review prior desk checking and debugging videos. And of course, this video also assumes that you're familiar with lists, including passing them as parameters to functions.
Before we get started, I'm going to quickly give you some tips for how to get the most out of this video. First, if you have problem solving with Python, read up through Chapter 6. If you don't have it, you can still learn a lot from this video. Open up idle and follow along with Python as I work. Sometimes I'm going to suggest you pause the video and complete some steps on your own. When I do that, pause the video and do your best to complete the steps on your own. The way to learn to program is by programming. You can watch and learn if you work along with me. Remember, you can always pause the video and try something, or go back and watch again. You don't have to wait for me to tell you to pause. There are some automated exercises in the description of this video. The exercises work with the same code or similar code to the code in the videos. After you've completed the video, try the exercises to cement the concepts in your mind. Now let's get started.
We will debug this program called inventory.py. This program is a tiny piece of a text adventure game in which the player has an inventory and there are items in the player's location that they can add to their inventory. A list is a great way to store both the user's inventory and the items in a location. This is just a tiny program that illustrates code that would transfer an item from the location to the player's inventory. Let's run it first. When I run the program, it first shows me that my inventory is empty, and then it gives me a list of items that I can see and asks me what I want to pick up. So it tells me there is a well-read Python textbook, but we all already have one of those, right? So we probably don't need it. There's gum, and I'm not sure if that's a pack of gum or not. There's 2 nickels, and there's 1 ring to rule them all. And as tempting as the 1 ring is, I know that it only brings destruction. So I think I'll choose the 2 nickels. Now, in this little program, I need to type that exactly as I see it, or it won't be added to my inventory. So I'm going to type 2 nickels, exactly as I see it, and now it tells me I have 2 nickels. Okay, so I said it was a tiny little program. It's really just going to help us understand some concepts related to lists and debugging and desk checking a program with lists. Let's take a look at the code. The program has 3 functions. Show items, which takes a list of strings as a parameter called items, and a string as a parameter called heading, and returns nothing. A function called pickup, which takes 2 lists of strings as parameters, one called inv, short for inventory, and one called items, and also returns nothing. And finally, main, which takes no parameters and returns nothing. And we can see that at the bottom of the script, we have 1 executable line of code, which is a call to main. So main is where our execution begins. In main, we have 2 variables, annotated and initialized, the inventory list of strings, which is initialized to the empty list, and the items list of strings, which is initialized to the hard-coded or literal values that we're already familiar with, from the Python textbook to the 1 ring, both of which could have major impact on your future. And then 3 function calls, show items, passing in the inventory, pickup, passing in the inventory and the items, and show items, again passing in the inventory. Remember that the program shows you your inventory, asks you what you want to pick up, and then shows you your inventory again. Each of our function calls handles one of those actions. Let's debug this first. To do so, I'll start the debugger. Check the source box, and then rearrange my windows so I can see the debugger window, the code, and the console. So we'll run the program, and we'll use the over button to get us down to the call to main. And then we'll use step to go into main. Now, I'll step over the creation of the 2 lists, And then we can see the lists in the locals area. Inventory is an empty list, and we see the first and last elements of the items list with an ellipses between them. Now I'm going to step over this first call to show items. I wrote this function because there are 3 places in this program where I display a list one item at a time, and so it made sense to create a function to do that, but it's really not that interesting. The interesting function is the pickup function. So I step over show items, and in the console I get the message that I have nothing. Now I'm going to click step on the call to pickup because I want to go through this code. Now, I'm passing 2 parameters. The first is inventory, and the second is items. So these values will be copied to the formal parameters called inv and items. Now, when a list is passed as a parameter, the whole list isn't copied. The list exists in a place in memory called the heap, and what is copied is basically the address of that place in memory. So we have 2 new variables here in pickup, inv and items, but because I passed references to the lists inventory and items from main, they are pointing to the same 2 lists in the heap. That means that any changes I make to those lists here in pickup will be made to the lists in the heap, and those are the same lists referenced by the variables back in main. Now this function is supposed to change these lists. If the user picks up an item, it should be removed from the items list and placed in the inv list. That's the way it's supposed to work. But we do have to be careful that we don't write functions that change lists that shouldn't change the lists. In those cases, we should copy the lists before passing them as parameters. And now, this is just an aside. If you find what I'm about to say confusing, just ignore it for now and revisit it when you're a more confident programmer. All of Python variables are stored in the heap. If you pass a parameter that is immutable, that can't be changed, then you don't have to consider that it might get modified in a function. If you pass a parameter that is mutable, that can be changed, like a list, then you do have to consider that it might get modified in the function. And the reason this might seem a little confusing is that mutability is a little bit hidden from you. You might think integers and floats and strings are mutable, but they're not. If I have a variable x that points to the number 4, and then I change that by writing an assignment statement, x equals 5, what happens is that x now points to a different number in memory. Now it points to 5. It's not that the place in memory was changed from holding 4 to holding 5. The 4 is still in its original place in memory, but x now holds a different memory address. This can be made visible by looking at the ID of a variable or literal, which is equivalent to its memory address. If I set x equals 5, and then look at ID x and ID 5, they're the same. If I then set x equal to 4, and look at ID x, it's different now. And if I look at ID 4, well, I can see that's the same as ID x. So the variable x now references a new memory address in the heap, the one containing 4. Again, don't worry about that right now if it's confusing, but I felt obligated to mention it so you don't have a misconception about the way Python is representing data behind the scenes. Okay, so back here in pickup, I have a reference to an empty list called inv, and I have a reference to a list with 4 strings called items. And again, the references are new, but the lists are the same lists in memory as the lists inventory and items from main. We're on the first executable line of code, which is a call to show items. We can step through that function now, just to see how it works. So I'll click step, and we go into the show items function, passing in 2 parameters, the items list and the heading UC. And for the first line of code, it prints the heading UC. And then there's a test if len items greater than 0. And we can see that the list is not empty. So that test is true. And we click over. And now we have a for loop for item in items. So the variable item will take on each value in the list items. And for each of those values, the body of the for loop will execute. So we click over, and item takes on a well-read Python textbook, and that is printed. Then we go back to the header of the for loop, click over, and item takes on the next value in the list, gum, and that is printed. And we click over and go back to the top of the for loop, click over, item takes on the new value, 2 nickels, and that is printed. Click over again, item takes on the last value in the list, 1 ring to rule them all, that is printed. Click over and we go back to the header of the loop, but there are no more values in the list, and we are done with the code in the function, so we return to where the function was called in pick up. This is an input statement allowing the user to pick up one of the items that was just listed. Let's type 1 ring to rule them all at the prompt and press enter. And we can see what I typed, 1 ring to rule them all, is in the variable choice. Now we have a test, if choice in items. So Python will check to see if the value referenced by the variable choice is a value that's in the list items. And it is. So we go into that conditional code. And here in this conditional code, we're going to modify both lists. So the first line is items.remove choice. Now the reason I chose 1 ring is so you could see the value in the locals area get modified. Because if I had chosen gum or 2 nickels, you wouldn't have seen that because those were elided. But when I click over, you can see now that items consists of only 3 items, the well-read Python textbook, gum, and 2 nickels. And now we're on the line inv.append choice, and I'll click over. And now you can see that inventory, which was previously empty, now contains 1 item, 1 ring to rule them all. And there's no more code to execute in that function, so we return to main. And you can see that here in main, those 2 lists were modified. The variable inv and the variable inventory reference the same list, so when we appended to inv, the list was changed, and now inventory references a list with 1 item. The same with the variables items and items, they both referenced the same list, so when an item was removed, they both now reference the list with the item removed. And now there's one more line of code, a call to show items, and that works the same as before, except this time we're passing in inventory, so I'll step over it, and it displays the value that's in the inventory list. Okay, so that's debugging a program with lists, and I'll be honest, the idle debugger isn't really great at showing you lists because it elides the list and doesn't show you all items. We can do better by desk checking, so let's do that. And I'm going to do something I haven't done before with a desk check table, and that is have an area for the heap. So I've opened the program in Notepad++ to show line numbers, and in my desk checking table, I'll have a column for the line number and sections for 2 functions, main and pickup, because I think we'll just desk check pickup and not show items. In main, I have variables inventory and items, and in pickup, I have parameter variables inv and items and local variable choice. I'll also have columns for input, output, and as I mentioned, the heap. In the heap, I'm going to show 2 columns, one that I'm going to call address or ID, and it's not really going to be memory addresses because we have no way of knowing where data will be placed at runtime, but it will represent the memory address or ID or location of data, and value, which is the value stored at that memory address or ID or location. Now I've put a very thick border between the heap and the rest of the table because I'm going to show the heap contents changing as we desk check, but I won't have a separate heap for every line of the desk check. You could do that, but you would need a lot of space in the table that I don't have here. If you're following along, feel free to draw a new copy of the heap for every line of the desk checking table to show on exactly which lines changes are made. Execution begins on line 41 with a call to main. So we jump into main, and the first executable line in main is line 29, which annotates inventory as a list of strings, but it also initializes that to the empty list. This allocates memory in the heap. So let's put address 1 as the address or ID or location, and at that location we'll put an empty list as the value, And the reference to this new list is inventory in main. So I'll put the address in the inventory column. I've grayed out the variable columns in pickup because that function isn't executing, and those variables do not yet exist. The next line to execute is line 30, and that extends over several lines and is another list annotation and initialization. This time the list contains 4 literal strings, and so I'll put that over in the heap, and I'll give it an address ID of 2, and put that in the items column in main. The next line to execute is line 35, and that's a call to the show items function, passing the reference to inventory and the literal string you have. As with the debugging session, I'm going to skip over this and jump to the next line. So that function will execute, the empty inventory will be displayed, and we will return to main where the call was made. The next line to execute is line 37, the call to pickup, passing in the references to inventory as the first actual parameter or argument, and items as the second actual parameter or argument. So let's go to pickup. And on line 16, the header, we have inv as the first parameter and items as the second. The references are copied into inv, so that's 1 in inv, and items, so that's 2 in items. Note that these reference the lists in the heap. Execution proceeds to line 20, which is another call to show items, this time passing in items and the literal string UC. Again, I'm going to skip over the call, so this is going to print the full inventory to the console and then return. We proceed sequentially to line 21, which is an input statement with the prompt, "What do you want to pick up?" And let's have the user type in gum. So that will be an input, and it will also be in the variable choice. Now on line 22, we have an if statement with the test choice in items, and gum is in items, which we can see by looking in the heap at the list at address 2. So that test will evaluate true, and we will execute the 2 conditional lines of code on lines 23 and 24. On line 23, we have items.remove choice. Items is at address 2 in the heap. So we will remove the value stored in choice, gum, from that list. On line 24, we have inv.append choice. Inv is at address 1 in the heap, so we will append the value stored in choice, again, gum, to the end of our empty list in the heap. Now, that is the end of executable code in function pickup, so we return to main, where it was called. Let's take a moment to notice that because we passed references to lists in the heap to function pickup, When the values in the heap were changed in pickup, they were changed for our references back here in main. It's one set of values. So the variables inventory and items in main still reference addresses 1 and 2 in the heap, and those lists were modified in pickup. Execution now proceeds sequentially to line 39, which is another call to show items, this time passing in inventory and the literal string you have again. Again, I won't step into this function and execute the code, but we know that it will print you have and the values in the inventory list, which is the one value gum. And finally, we are finished executing main, and we return to the line of code where main was invoked, line 41. The function main returns no values, and there is no code after this line, so we're done. I do recommend stepping through by hand or desk checking this program a few more times with different values. Try entering values that are and are not in the inventory, and step through the program in the debugger to check your work.